Hello everyone, hope all is well. So today we're going to be starting 5-4, solving radical equations. This is going to be more on the algebraic side, so I think you guys are going to enjoy this more than graphing. So what I want you to think about is in the past when you solve an equation, think about what the inverse of squaring something is. How do we get rid of x squared? How do we get rid of the squared? By square rooting. So what we're going to be talking about today is the exact opposite. What if I have a radical equation, so an equation with a square root, a cube root, fourth root? Well, how would I get rid of a radical? Well, the inverse would be raising it to a power. So that's what we're going to be talking about today. The nice thing about these equations is that you could always check your work by substituting your answer back into the original equation, making sure it works. And if it doesn't work, it either means you did something wrong or it's possibly an extraneous solution, which we're going to be talking about as well. All right, so let's take a look at example 1. Here it says solve the radical equation. For every single radical equation, step 1 is always going to be to isolate the radical if you can, okay? So step 1, isolate radical if you can. So notice here, what is my radical? The radical is the square root of x plus 5. That x plus 5 is inside of that radical. How do I get the square root of x plus 5 by itself? Well, I have to add 1 to the other side of the equation. Now that the square root is by itself, well, what's the opposite of a square root? Well, squaring. Whatever you do to one side, you do to the other. The square root of a square, squaring a square root will cancel it out, so it'll just leave me with x plus 5. And here, 4 squared is 16. Finally, I subtract 5 over, I get x equals 11. Now I need to check my work to make sure it works, because if it doesn't, that could mean that there's an extraneous solution. So in the original problem, the square root of 11 plus 5 minus 1, does that equal 3? Well, 11 plus 5 is 16. Is the square root of 16 minus 1 equal to 3? Well, yes, because 4 minus 1 is 3. So there we go. So step 1, isolate the radical. Step 2, inverse operation. Step 3, solve for x. And step 4, check your answer. All right. Let's look at part B of example 1. So part B of example 1, now what is in the root? We have a cube root this time and only the x is in the root. So to isolate the radical, all I have to do is subtract 2 over. Let me lower that volume. All right, so I'm going to subtract 2 over, leaving me with the cube root of x equals 2. Now, what's the opposite of a cube root? Well, cubing, right? Raising to the third power. So that will leave me with x equals 8. I check my work. Is the cube root of 8 plus 2 equal to 4? Well, the cube root of 8 is 2. Is 2 plus 2 4? Yes, it is. Done. All right, now I want you guys to pause this video. I want you to turn to page 126 of your student companion, and I want you to try it example 1A and B. When you're ready, you could unpause the video and watch me go over it. All right, for 1A, notice I'm first going to subtract 3 over. I'm then going to square both sides, and I get x equals 6. I check my work, and it works. For the next one, I see here the radicals are already isolated, right? Like everything is inside of the cube root, so I could just cube both sides. I get x equals 9. I check my answer, and it works. Done. All right, let's take a look at example 2. So looking at example 2, it says rewrite a formula. So the suspension cables from the Golden Gate Bridge's towers are farther above the roadway, near the towers, and closer to the roadway near the middle of the bridge. you can figure out your distance from the middle of the bridge, x, in feet, and the height of the suspension cable, y, in feet. So the height of the suspension cable represents y. The distance from the middle of the bridge represents x. About how far is the cable from the roadway when you are 200 feet from the middle of the bridge? So are they giving us x or y in this case? They're giving us 200 feet from the middle of the bridge. And x represents the feet from the middle of the bridge, okay? So I'm going to substitute 200 in for x. So we have 200 equals the square root of y minus 220. Over 0.010583. So now, to solve this equation, I need to isolate the square root. Well, this decimal here is not in the square root. So I'm going to multiply both sides by 0.010583. 0.010583. Go ahead and type that into your calculator. 200 times 0.010583, and I get 2.1166 equals the square root of y minus 220. Now that the square root's by itself, I could go ahead and square both sides. I get 4.48 approximately equals y minus 220. I add 220 over, and I get 224.48 equals y. So what does y represent again? Well, it's in feet, so 224.8 feet. And it represents how far the cable is from the roadway. All right. Go ahead and pause this video. Try example 2. Try it. All right, so it's saying, what is the equation for stopping distance in terms of the vehicle's speed? Okay, so in other words, it wants us to rewrite the equation so that it is d equals, because d is the stopping distance, and in terms of the speed v. So I basically want to solve for d here, just so I could get it as a function of speed. So in order to do that, what's the first step of getting this square root by itself? Well, I need to get rid of the 3.57. So I'm going to divide both sides by the 3.57. And now we have this. To get rid of the square root, I square both sides. Make sure you're squaring everything on that side. So you get d equals v over 3.57 quantity squared. And that is the equation for stopping distance in terms of the speed, right? Because this represents the speed and this represents stopping distance. All right. Moving on to example 3. All right. So now we see we have the square root of 3x minus 2 equals the x minus 4. Now, is the radical already isolated? Meaning, is everything that is inside the square root on one side? Is there anything outside of the square root here? No, the 3x minus 2 is all in that square root. So I'm already ready to square both sides of the equation to get rid of the square root. Now, squaring a square root is inverse operations. However, what is x minus 4 quantity squared? It is surely not x squared plus 16, right? That is not true. You are never allowed to distribute an exponent whenever you see a plus or minus. So I know you're thinking this right now. What do we do if we can't distribute the exponent? What does it mean to square something? It means to write it out twice and multiply it by itself, right? When squaring means multiply by itself. Anytime you have a quantity, meaning 2 or more terms separated by plus or minuses, we cannot distribute an exponent. So we're going to write it out twice, and we're going to FOIL, giving us x squared minus 4x minus 4x plus 16. So now I'm going to combine like terms. And we have this. Whenever we have an x squared and an x in the same equation, what's that a hint that we're going to have to do since it's impossible to isolate x? That means we're going to have to factor, right? Anytime we see an x squared and an x in the same equation, we cannot isolate x, therefore we're going to have to factor. In order to factor, I need this equation to equal 0. So I'm going to move everything to one side so that it's equal to 0. Giving me x squared minus 11x plus 18 equals 0. Now I need a factor. What multiplies to 18? That adds to negative 11. Multiplies to 18, adds to negative 11, negative 9, and negative 2. Because a is 1, and only because a is 1, I do not need to use grouping. I could jump to my factors. Now that I have my factors, if I set x minus 9 equal to 0, I get x equals 9. If I set x minus 2 equal to 0, I get x equals 2. I cannot circle my answers until I check. So first I'm going to check x equals 9. I'm always going to check it in the original equation. So 3 times 9 minus 2, does that equal 9 minus 4? So everywhere I see an x, I plugged in 9. So that's 27 minus 2. Does that equal 9 minus 4 is 5. Is the square root of 25 equal to 5? Yes, it is. So that works. Now I'm going to check x equals 2. 3 times 2 minus 2. Does that equal 9 minus 2? I'm sorry, not 9 minus 2. What am I saying? 2 minus 4. So here we have 6 minus 2. That's 4. Is the square root of 4 negative 2? Now I know what you might be thinking, plus or minus. Do you see a plus or minus here? No. What is the square root of 4? The square root of 4 is 2. A square root can never equal a negative number. So therefore, 2 is extraneous, right? The square root of 4 is 2. It is not negative 2. So therefore, we see an extraneous solution. All right, let's try another one. All right, for part B, it says x equals 2 is an extraneous solution. Why does this extraneous solution arise? Well, we kind of just discussed this already, but when I substitute the equation back in, it tells us that a square root is equal to a negative number, and I know that can't be the case. So notice here, it's saying use the graphs and show what they look like. Okay, so here we have a square root equal to a linear function because this is the orange graph, a square root function, and x minus 4 is mx plus b. That's a linear function. So here it is. We only see one point of intersection there, right? So therefore, we can only have one solution. If I were to look at these two functions after I squared both sides, notice I see 2 points of intersection, which is why the extraneous solution arises, okay? But however, we know that looking at the original two graphs, there's only 1 point of intersection. Okay, pause this video, go ahead and do example 3, try it. All right. Notice here, the square root is already isolated again. So I'm going to square both sides, giving me x squared equals 7x plus 8. Right, when I go ahead and square both sides to get rid of the square root. I see an x squared and an x. I'm going to move everything to one side to get it equal to 0, and now I have to factor. What multiplies to negative 8, that adds to negative 7, right? What multiplies to AC adds to B. We get negative 8 and positive 1. Again, because A is not 1, I could jump to my factors, x minus 8, x plus 1. So I get x equals 8 and negative 1. I then have to check my work. So I'm going to check x equals 8 first. Is 8 equal to the square root of 7 times 8 plus 8? 7 times 8 is 56. 56 plus 8 is 64. Is the square root of 64 equal to 8? Yes, it is. That works. Now I'm going to check x equals negative 1. Negative 1 equals the square root of 7 times negative 1 plus 8. That's negative 7 plus 8, that's 1. Is the square root of 1 equal to negative 1? No, it is not. The square root of 1 is 1. So therefore, negative 1 is an extraneous solution. Now, just because an answer is negative doesn't mean it has to be extraneous. So you always have to check. In addition, just because you get 2 answers doesn't mean that one of them has to be extraneous. It's possible that both of them are extraneous. It's possible that none of them are extraneous. So you always have to check. Okay, looking at our next triad, I'm going to square both sides since the radical is already isolated. Now, on the left, anytime I have a quantity squared, I'm going to write it out twice, and I'm going to FOIL. So x plus 2 times x plus 2 is going to give me x squared plus 4x plus 4 when I combine like terms. I skipped a step there. Equals x plus 2. I'm now going to get this equation equal to 0. X squared, I'm going to subtract x over, so that gives me 3x. I'm going to subtract 2 over. Now what multiplies to 2 adds to 3, 2 and 1. So I get x plus 2, x plus 1 equals 0. Therefore, x equals negative 2 and negative 1. I now have to check my work. I'm running out of room here, so I'm going to check it over here. I'm going to check x equals negative 2 first. Negative 2 plus 2, does that equal the square root? Oops. The square root of negative 2 plus 2. Well, negative 2 plus 2 is 0. Does that equal the square root of 0? Yes, it does. So this one works. Now I'm going to check the other one. Negative 1 plus 2, does that equal the square root of negative 1 plus 2? Well, again, I get 1. Square root of 1 equals 1. So therefore, it also works. So both of these are my solutions. They both work. Questions on these? Make sure you join me on Zoom if you do have questions. Okay. All right. So we are going to stop there. I'm going to complete examples 4, 5, and 6 in next class. So make sure you tune in for that. So make sure to practice these because these equations will get harder, okay? So make sure you complete your assignment for today and tune in next class to finish the notes for 5-4. All right, have a great day.